Let's do a couple more examples like that. Use a trig function to find the value of x, round to the nearest tenth if necessary. So on this one, we have a 60-degree angle. The side x, the side we're trying to figure out, is adjacent to the 60-degree angle. 14 is a hypotenuse. So the trig function we want to use is cosine, because that is adjacent over hypotenuse. So we will set the cosine of 60 equal to the measure of the adjacent side, which is x, over the hypotenuse, which is 14. We know 60 is part of our special triangles, so going up again to our special triangles. This time, since we're doing adjacent, we're going to use the 60-degree angle, and adjacent to the 60-degree angle is 1, and the hypotenuse is still a 2. So we'll replace the cosine of 60 with 1 over 2. Cross multiply to solve that, so we get 2x equals 14, which means x equals 7. No rounding necessary on that one. 3b, the x is a hypotenuse. That's what we're trying to find, and the 10 is an opposite. So sine is what uses a hypotenuse and the opposite side. The formula for sine is actually opposite over hypotenuse. So I'd set the sine of 45 degrees equal to the opposite side of 10 over the hypotenuse, which is x, which is what we're trying to figure out. Well, the sine of 45 is the square root of 2 over 2. Set that equal to 10 over x. We can cross multiply, so we get x square root of 2 equals 20. We would divide by the square root of 2. And if it didn't say to round to the nearest tenth, I would just rationalize the denominator. But since I can round to the nearest tenth, I'll just go to a calculator and take 20 divided by the square root of 2. And round it to the nearest tenth, we get about 14.1. So x is approximately equal to 14.1. Trig is often used to do real-world examples when you're trying to measure the heights of things that you can't measure directly, particularly like tall buildings or trees or mountains or cliffs or anything that you just simply can't drop a tape measure from the top to the bottom to measure. To calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer to measure the angle from his eye to the top of the building. If his eye level is at 6 feet, how tall is the building? Well, one thing I want to point out in this picture, this is not a very good picture that is shown, is because it says the measure from his eye level to the top of the building is 76 degrees. And the picture kind of shows that that's from the bottom there, from his feet, which is not what's being actually measured. So the picture more accurately should probably be more like this. That would be his eye level. That would be 76 degrees. And that this would be 6 feet from his eye level to the ground. So that's kind of important at the very end of the problem. So regardless, the side we're trying to figure out is D. And compared to the 76-degree angle, that is an opposite side. And the 200 feet is a measurement that we do know. So that would be 200 feet from his eye level as well. And so that is going to be adjacent to the 76-degree angle, and that is going to be our tangent formula, because tangent is opposite over adjacent. So we would set the tangent of 76 degrees equal to the opposite side, which is D. We're trying to figure that out. And the adjacent side is 200. However, we have not talked about a 76-degree angle yet because it is not one of our special angles. It's not a 30 or a 45 or a 60. So this is where we need to use the scientific calculator. It's very important that you have your calculator set up properly and know what type of calculator you're using. Email me directly if you need to help setting up your calculator. But for right now, make sure it is set to degree mode. It says either DEG somewhere on the screen, or maybe it just says a D depending on your calculator model. A graphing calculator might have a different setting. Refer to your user's manual for those. Once you get it set to degree, and make sure it's not set to rad or R or grad or G, we will talk about those at a later date, you are going to find the tangent of 76. So the tangent of 76 would be about 4.0108 if I go to 4 decimal places. Equals D over 200. And then to solve for D, I would just multiply both sides times 200. And if I just leave the tangent of 200 that I just figured out on screen, I would just leave it on screen and take it times 200. And to the nearest foot, you get about 802 feet. Then remember, that's from his eye level. He's 6 feet tall. We would still need to add 6 feet for his eyes being 6 feet off the ground, which means he has measured a building that is about 808 feet tall. Inverse trig ratios. Inverse trig ratios are used when you know the measurement of the sine, cosine, tangent, or any trig function. The inverse ratio will tell you the measure of the angle. The notation for inverse ratios is the trig function with a -1 after it. That does not mean it is sine to the -1 power. It means that it is the inverse of sine, which could be used to figure out the angle measure. So you can see down here in the first example, if we know the sine of some angle is 1/2, then its inverse would be giving us a 30-degree angle, because the sine of a half comes from a 30-degree angle. We can use inverse functions to help us measure the actual angle measures from a triangle. So part A wants us to find the measure of angle N. Angle N being right there. So compared to angle N, which is what we're trying to figure out, the 6 is an opposite side, and the 10 is a hypotenuse. So that means that the sine, because that's the opposite over hypotenuse formula, the sine of N must equal the length of the opposite side of 6 over the hypotenuse 10. So to figure out the sine of N, we're going to do the inverse sine. So on your calculator, above the sine button, it probably says sine to the with a -1. That is the inverse sine. You have to either hit shift or second to get to that. So again, depending on your calculator model, if you have a two-line calculator, you would hit shift sine, and that will bring up sine -1, and then 6/10. Close your parentheses, and it tells us that it is about 36.9. That is the actual degree measure of angle N. It is about 36.9 degrees. And even though the question doesn't ask it, we can also figure out the measure of angle L, because we know that the two acute angles in a right triangle have to add up to 90 degrees. So the measure of angle L is going to be 90 degrees minus whatever angle N is, which is 36.9, which means angle L must be 53.1 degrees. Part B wants us to find angle B in a different picture. So angle B being right there. The sides that we know are the 8, which is an adjacent leg, and 16, which is a hypotenuse, and that is going to be cosine. So if we set the cosine of B equal to the adjacent leg of 8 over the hypotenuse of 16, notice that 8/16 can simplify to 1/2. And going up to our special triangles, the 60-degree angle right there has an adjacent side of 1 and a hypotenuse of 2. So that means that B must be a 60-degree angle. You could figure that out with a calculator, but I really want to encourage you to remember your 30, 45s, and 60-degree angles, because you're going to see those triangles over and over and over again in trigonometry. And even though your calculators might give you estimates for things like the square root of 3, because that's what one of the special sides are, knowing those triangles will give you the exact measurements, which will be important later on.